Okay, this is going to be a brief video tutorial on using GeoGebra and just talking about how you construct triangles and the different things that you should have gotten out of uh, session 15. So I'm going to go over some of this. The first thing you're supposed to do is write down triangles with different lengths and different sides. Okay, this is your GeoGebra screen. I'm going to show you a few things about it that you can do that so you know how to use it, because this is a really nice tool. It's a great technological tool. It's an excellent teaching tool, and kids actually like playing with this once they learn how. First thing is this button right here is how you move your screen around. So I want just the upper quadrant, so I'm going to move it. So once you do this one, your choices are zoom in, zoom out, etc., etc. But basically, this is the main one you want, is the one that moves the graphics. All right. When you click on this, you can move your points, or you can move around a point. Usually, you want to move a point. Over here in settings, under graphics, you can add a grid. Here's your x-axis. This tells you, let's see, your x-axis, this tells you to show numbers. It shows you, 8, 9, 10, etc., etc. The ticks in this case are at 1. The y-axis, same thing. Usually these are all right. And this is if you just want the quadrant, the positive or the negative direction only. And then this, you can add a grid. So if you show the grid, what it does is it adds these on, which I kind of like to do. So I always show the grid, and then I just move the axis out of my way. You can say only the positive axis and only this will show, but it's just as easy to move it. Okay, so I'm going to go to this problem in the homework where you were told to where was it? Choose any two measurements. I think choose length sides of 7 and 6.7, and there's actually 5 ways to do them, but I was going to go ahead and construct them on this right here, and that way you could kind of get the hang of using this. Okay, so we have two side lengths that are fixed, 6.7 and 7, and the third one would just be dependent on what the first two were. So what you do is you go to your line segment, and you're going to choose segment with a given length. Now this, on the very bottom, you could actually, figure out where 7 is by just adding, but we'll go ahead and do it this way. So this is going to go to segment with a given length. We'll go ahead and start on right there. Then you just type in your segment length, which is 7, and it automatically does it for you, okay? And then you go to segment length. And I'm going to go ahead and click on this point, and then it asks me, and I say 6.7 and push OK. And what it did is it put this point on top of that one. You see that? So the point C was, the default for GeoGebra is to make a horizontal line. So the first line I chose, length of 7, was out to B. The second point I chose, 6.7, was out to C. So now I'm going to click on this, which again, it's move or move around point. Usually you want move. Usually you just want move. I'm going to grab point C and I'm going to move it up here, okay? Now, this is A, this is B, and when I first did this, I kept forgetting which one was 6.7 and which one is 7. So you can actually click on the line itself and go to Object Properties. And when it says here show label, you have a choice name or value. If you click on value, it actually shows you the length so you can remember which one is the which. So I'm going to right click on this line, go to Object Properties, and I want to show value. So that's your, and again, that was a right click, and this is what kicks up. You just want to choose value. And this way I know which one is 6 and which one is 6.7. Okay, so now the first choice was to put your angle measurement between here at angle A. Oh, and you can also click on the move, and whatever you touch next gets moved. So you can move your B and your A and your little labels out of your way so that they're not in the way, and you can do that also with your numbers, okay? So that's a nice thing. You can scoot things around by pushing on move. Okay, so, and also you want to turn trace. Okay, it's not good. All right, so now I'm going to go ahead and click on this angle, which the pictures match what they do, angle with a given size. Now what you do is, you remember how you name an angle by A, like this would be angle BAC? You have to name your angle. So I want this to be angle BA, and then it's going to ask me for my size, which was, it was 65, that's right, it was 65, and you push OK, and it's going to give you a point B that would give you a 65-degree angle. Okay, now, as far as how far this is, this was 6.7. I don't know how far this is. It might be the same, I don't know until I connect it. So what I'm going to do is I'm going to click on just a segment, and I'm going to go ahead and click on this and make a segment from here to here. So this segment is at a 65 degree. But this is my 6.7 length one, if that makes any sense. This is the one I made at 6.7. I'm not sure how big this one is. Let me see what happens if I click on it and I go to Object Properties and choose Value. I haven't tried this yet, actually. This is 7. Oh, so this made the same length as this one. So if I click on Move, let's see if I can shrink this down to 6.7. No, it's not going to let me do that. So what I'm going to do is I'm going to go ahead and roll this one over it so that it's exactly on top of it, because that one is the right length. And then I'm going to right click on this, the one that's too long, and I'm going to push delete. Okay? So now my angle measurement is at 65 degrees. Now it got rid of the 65 degree mark. You can get that back by just clicking on, there's two ways to do this. You can just click, I'll show you the other way in a minute, but you can click on angle, and then you actually name the angle. This is angle BAC, and it tells me it's 64.96. Okay, it's not quite at 65, because remember I moved it a little bit. I don't know if you can tweak it to move it up 65. Yeah, this 65.02. I think that's the best we're going to get. But anyway, that's a 65 degree angle. And then for your last side, you're just going to click on connect the two dots, and there's your final side. So you have a 7, 6.7, and the 65 degree angle splits the two of them. Okay. Let's see. Let's do another one. I'm going to go ahead and grab this and scoot. Well, I'll just scoot it over a little bit. Okay. The other choice you had was to do, again, I'm going to start with the same one. I'm going to start with 7. Segment with a given line. So we'll start here, and then I'll go ahead and put in 7, and it's going to draw a horizontal line. Now, what I did is then I said, okay, I want an angle that has a given size of 65. So this time I went like this. I said, okay, I want it to be on this side now. And wait, hold on, I didn't quite do this. Then I drew my next angle that was a given measure, segment with given length, and it clicked on D, and then I said 6.7. Whoops, what happened there? 6.7. I pushed OK. And then I went ahead and clicked on this arrow because I want to move this point. This new point is F. This is the point. Okay, I want it out of the way. And then I wanted to choose my angle size. And so I said, well, this time I want the angle over here. So I clicked on this, and I clicked on this, and I clicked on 65, and it put it down here. I thought, oh, okay. So evidently, you have to go left to right for your angle measures to get them inside of the object. If you go right to left, it always puts it to the left of the object, so it put it in the wrong space. So up here, if you look, there's an undo, that little circle, you can undo what you just did. So what I'm going to have to do is delete this line, and then I'm going to put the angle measure over here, and I'm going to put the 6.7 line over here. Okay, so again, I'm going to do the, okay, here's my 65 degree angle. And and again, I'm just going to make a segment out of that. And I don't know how long this is right now. I don't care, okay? Then on this one, I'm going to go ahead and make my, my segment that I want the size from. Only I'm going to put it over here because I want it to be on this side. Let's see what happens. This might go horizontal again. Yeah, there it is. Okay, so I got to grab the grid up here and scoot it over so I can find the end. Then I'm going to click on New because I want to move this point to where it hits that. Okay, there we go. Okay, so this is an example of oops, let me mark these and you'll be able to see. So let's go to Object Properties and we'll go to Value. So this was my 7-inch line. Object Properties, Value, and this is my 6.7-inch line. So see, on this case, the 65 degree angle is not between the there are two. Let me get this. Oh, this one I want to keep in here. The D I want to get out of here because it's confusing. Okay, that was just the letter for the. Okay, so I'm just moving things around. So I have triangle DEF. And here, the 7 and the 6 point, the 6.7's traded sizes, but the angle has not. The angle is still over here on the left side. So now the 65 degree angle is not between the 6.7 and the 7. So now what we're going to do is examine the different types of triangles, see if there's any other way to draw that. If I keep the 65-degree angle between the 6.7 and the 7 degree, the 6.7 length and the 7 length. There's really no other way to, to draw this triangle. Let's go ahead and put a size on this real quick. I've gone ahead and changed the length to where you can see what the length is. Okay, so this is a 7.37 side. When this is 6.7, this is 7, and this is 65 degrees, we get 6.37. So let me move that. Whoops, that's not supposed to come out. Let me move that out so we can see it. All right. Now, what I'll do is go ahead and do some triangle constructions and see if there's any other way to do that. So what we're going to do is we're going to see if we can construct this triangle with a 60-degree angle in any other way. So we're going to go do a little bit of triangle construction down here. So let's go ahead and start. We can go ahead and start with a base of a 6.7 or a 7. It's usually easier if you make your longest side your bottom, but that doesn't have to be the case all the time. So let's go ahead and do the 7 on the bottom, just because when you make your triangles it works best if that's how you actually start them. So there's my 7-inch base. So I can see the value is 7. Further to the right. Okay, so let's do it here. So I'll do this and I'll make this 7. Okay, that way when I make my circle it won't be over here off of the axis. Let's try this again. Circle with radius. There's my center. I want my radius to be 6.7. Okay, because it's easier to do the angle measure here. So now I'm going to go ahead and make a segment and start here, and it goes to anywhere where it touches on the circle, and that's going to be 7. Let me mark that, and let me mark this. Values. Okay, so there's my 6.7 and my 7, and let me go ahead and get an angle measure in here. So the angle, this is, again, you just pull down here and you choose angle, and then you pick 3 points. HGI is the angle. Right now it's at 59.7, so I can go ahead and, again, I'm going to choose over here with the arrow, I'm going to choose this point to move, and I'll make it go to about 65. This is hard to do exactly. 65.08. That may be the best I can do. So this is one leg, this is the other leg. Let me go ahead and connect the segment and see how long this third leg is, because it's probably going to be exactly the same length as the one above. So if I go to name, value, okay, it ends up being 7.37, and if I click the grid here and go up here, it was 7.37, which is, that's hard to believe it's exactly the same, because I don't think I was on 65, but evidently I was close enough to where the length was the same. So this looks just like this one, all right? You'll notice this has 7 on the bottom, and it has 6.7 on the sides and the right side, and the angle measures between these, all right? Let's see if I can put the angle over here between this one, and if I do that, if that creates a situation where the side length changes. So now I'm going to go ahead and make another circle, and this is going to now be the center, and it's going to be 6.7, only I'm going to put the angle over here to see if it makes a difference, which it shouldn't. So this is now my 6.7, this is now my circle, so let's go over here, and anywhere on here should have a radius of 7. Oops, I didn't mean to do that. Okay, so let's try that again. Okay, so we're going to go ahead and object properties and value. Okay, so we're still doing 6.7. And now I'm going to go ahead and put the angle measure. Sorry, I'm moving these letters so they're not in the way. I'm going to go ahead and put this is the triangle I had originally. I'm going to go ahead, let me get rid of this real quick so it doesn't get confusing. Okay, so these two are gone. Now I'm going to go ahead and put the angle measure between these, and I figured out a way to do that. Since I have to go right to left, what I will do is I will start here. And that should, yeah, there we go. And this should be what okay, so that's a 65-degree angle. So again, I'm going to choose that point to move. Stop that. I'm going to choose this point, and when I do that and I go to 65, it's hard to control this thing. Oh, there I had 65.05. I couldn't get much. Oh, 64.99. Can't beat that. And then I'm going to draw a segment now between that side and this side. Now you'll notice this is no longer 65 degrees, but that's not surprising because, yeah, there we go. Because this is on the other side. So when I do that and I look at the measurement of this particular side by going to name and value, what I see is it is 7.36, which if you remember up here, it was almost identical, 7.37, and that's just because the angle measure is just off a tad. So basically, as long as you're putting the angle between 6.7 and a length of 7 two sides, your angle measure at 65 is always going to produce the same perimeter on any triangle. And if this is 65 and these are the same exact lengths, then that means all the opposite angles have to be corresponding. So the angle opposite, the side lane opposite of this angle has to be the same as the angle measure opposite 7, as same as the angle measure over here opposite 67. So if we were to, we could probably, whoops, I didn't mean to do that. I could do angle measures and you could see this one, let's see what this angle is. If we do this one, we do, I think you have to go left to right. Oops, wrong one, hold on. I didn't mean to do that. I wanted to do the angle measure, and I want to do angle. So this angle measure comes out to be 55.53. I thought that's what I got. Okay, this is 59.47. And if I go down here and check this one, this is going to be, let me click on the angle, 50.5, yep, there's the exact same number. And then here, if we go to this one, we see, okay, so let's compare these, 59.47, 64.99, which is basically 65, and then 55.53. So it doesn't matter. No matter how I draw this, I'm going to end up with exactly the same angle measure and exactly the same side lengths, you know, assuming that my angles were 100% right. So when the angle is between the two sides, there are no options. They end up exactly the same. So, so that part we know if the angle's between the two side lengths, which should make you think of angles. Let's see, side, angle, side, SAS. Where if your angle is between the two sides, you're going to get exactly the same measure. Now this is a case of side-side angle, where the angle is not between the two. And the question is, can you assume that you're always going to get exactly the same triangle like we did here? No matter what, we got the exact same triangle. Even if we reversed the direction and everything, it still came out to be the same. If I rotated this so that this side went up like this and this side went down like this, it would still end up looking exactly the same. There's no way, whether you reflect it, whether you rotate it, you're going to get exactly the same picture. The question is that true for this one? So let's go ahead and see what happens if I do that one. I'm going to go ahead and get rid of what I've drawn. I've gone ahead and marked all the angle measures on both of them, particularly this one, because this is the one we're going to look at now to see what will happen. And one of the things that I did also is I marked the side that changes. These are the fixed sides, 6.7 and 7. Here we have 7 and 6.7. Now I want to show you something. If you look at your circle, you can draw a circle all the way around, or I'm going to go ahead and draw a half circle or just a circular arc. And you do that by putting your first point in the center of the circle, which is this, and then the second point on what would be considered the radius or whatever, right? So let's go ahead and do that. There's my circle, or my half circle. Now the reason I did that is remember when we were doing circular constructions, just to remind you, this was your center and this was your radius was 7, and we drew the circle all the way around. This was 7. Oops, I wanted to do 6.7. Alright, so we'll do a center at this, and the center wanted to be 6.7. Okay, so this is basically what I've done is I've just done part of a circle. I guess it doesn't matter. You can use just the arc or the whole thing. In the end, it ends up being the same thing. Let me go ahead and get this out of the way because I want to be able to see the angle measure. Now, what I'm going to do is pay attention to how this arc cuts through this triangle base. This is sideways, so it would probably be, well, you just need to turn your head kind of sideways. This, I'm going to call this the base of the triangle. These cannot change lengths. The 7 has to be 7. and the 6.7 has to say 6.7, but this can change the same. Well, notice this radius is 6.7, so as long as I'm touching the edge of the circle, I've got a 6.7 segment, and the circle intersects with the base of this triangle here, which tells me that I could actually draw another line segment that intersected right there and make myself another triangle, and there it is. Okay, so notice my my length of my triangle is still the same. Hold on, I'm looking for a basic. I want value. Okay, the length of my triangle, it's still got 6.7 and it's still got a 7, but now, and it's still got this 65 degree angle that's not between the two angles. It's not up here, but it still makes a triangle with the base of this triangle. It's just an extremely obtuse triangle. So the angle measures of this are obviously completely different than the angle measures of this original one. But everything in red is the original triangle, which you guys can probably already see, but I want to make sure I'm not losing anybody. Everything in red was my original triangle. Okay? So there's my original triangle, and now I have this new triangle that's going to be in blue. So that's the new triangle. That's the new side of the triangle, and this is the new side of the triangle. And then I'm not sure I can know how to, if I change this to blue, it'll change this whole thing to blue. But this little piece right here, from here to here, is going to be the new side of the triangle. Okay, so this is the new bottom of it. So I've got this little skinny triangle. Notice both of these share the 65 degree angle. What this shows you is that when you have a side and an angle that's not between these sides, which is the SSA construction, you can draw more than one triangle. So you can't assume two triangles are congruent if they share an angle and that angle is not between the two sides. And that's pretty much what this particular construction shows. And that was the point of this homework right here, was to show, whoops, that wasn't supposed to happen. So what we've just done is we've kind of proven through some constructions a couple of theorems in triangle congruence. The side angle side was the first one. That's where you have two sides with an angle that's between them. And as long as the side lengths stay the same, then the angle that's between them and the angle that they share is also between them, then you're always going to get a congruent. There's no way you're not going to, all your triangles are going to be congruent. If you know two side lengths are the same and you know an angle, they all have, if you have three triangles, they have all the two side lengths the same and the same angle between these two side lengths, those triangles have to be congruent. All right. The other one is the side angle side, which is the one you have to be careful to spell the right way or it causes all kinds of commotion with kids, but is the SSA, which is the side angle, and that's the one we just did all these constructions on, where two sides are the same, and again they share two sides in an angle, but that angle is not between the two sides. It's not in the middle of them in either one of these cases. In that case, you cannot assume congruence. Okay, there's no way you can say it's congruent because you could get at least two, well, basically two different triangles that are not the same at all. They have different side lengths. Now they'll have the same angle, but the third side length and the other two angles are going to be different. Okay, the last one that I haven't done through the construction is the angle side angle, where they share two angles and a side. And the question is, will that produce congruence? That would be the million-dollar question. And that is one of the questions on the homework. So just to get you started, you're going to do some, you can do this with your protractor or GeoGebra. GeoGebra is kind of fun to do. I'm going to go ahead and construct a triangle real quick. And what I'm going to do is I'm going to start with the same side length for both of them. And I'll make it just different. So let's make, whoops. Okay, so let's see, that's going to be what? Well, actually, you know what? I'm going to pick a side length so I can control it. So let's go back and just pick one. We'll make a length segment of given, let's make it 7.5. Okay. And we'll go ahead and move that. Ah! Something just crawled across my foot. Okay, so let's go ahead and move this up like that. And I'm going to make the same one again, and we'll make this, and we'll just make this as a regular base. So this will just be 7.5. Okay, So there's that triangle, and so this is, remember this was angle, side, angle. So I'm going to go ahead and make 3 sides the same, because one of the postulates also that we're not going to do in here is side, side, side. If all 3 sides are the same, that means that the actual triangles are also congruent. But right now I'm just going to go ahead and make, let me go ahead and make, actually let's make a kind of a funky one. There's one, and we'll go ahead and make this. All right. So there's my triangle. So let's see what's, whoopsie, I didn't mean to do that. Okay, so we're going to do that. Okay, so let's go ahead and I'm going to see how long each of these are. I might make them, if they're weirdo numbers, I might make them a little bit easier to work with. Okay, and this is, okay, so I have a 7 point, let me go ahead and shorten this one just a little bit. Let's go to 6.05, that looks good. Okay, so that's good. 6 point, that way this is really close to 7, 3.2. I can replicate that. So this one is my, I can't even remember now what side that was. That was the 7.5 side, okay? So if I make, and then I'm going to go ahead and I'm going to check to see what these angles are. So let's go to the angles. So this one, let's see, you go left to right to get it inside the shape. I don't understand. Oops, that's not working. There we go. Okay, there's one. Left, right, left, okay. And then left, right, left. Okay, so these are respectively 68.4, 86.36, and this one is 25.24. So I'm off my 7.5. If I make this 68.4 and then 25.24, it should force my lengths to be exactly the same. So I'll go ahead and make a angle measure that was the same. And what am I trying to make one of these off? 7.5. I'm 25.24. Actually, we'll do the 68.4. 68.4. Okay? So that's that one. Choose my length. This is my starting point, and it's 3.2. 3.2. Okay, so that's more like it. So, whoops. So we're going to pick this, and I'm going to move this up here to where it's right about on top of that angle. There we go. Okay, and then I'm going to see if I, you know what? Okay, if I pick this angle measure now to be 68.4, is that right? Yeah, 3.2 was off the 68.4, and then this angle measure was 25.24. So how do I force that to be that? Well, I guess I'll just put a segment there, and then I'll see what it ends up being. Okay, so let's go ahead and do this. Okay, so, oh, I picked that length, that's right. Well, let's go ahead and do this and see if it doesn't put it right on top of that. So now I'm going to go ahead and see what this angle measure is. It's kind of a pain. Okay. Move this out of the way. Okay, so I have a 33.86. To match this, there's the 7.5 for this one. The 7.5 length is up here. It has a 68.4 on one side and a 25.24 angle degree on the other one. Here's the 64.84 angle measurement. Let me go ahead and put the length on that. It's going to end up obviously changing, but that way we can see it. And then I'll make sure I can see the length on this one as well. Okay, so there's my two lengths. This needs to be 25.24, so I'm gonna shrink this till it's 25.24, or there's 25.23, and if I push it out to where it's right on top of that, button, that dot, well, 25.14. So let's see. This is 6.99. There's the same length, 7.53.2. So this shows that the side angle also gives you two congruent triangles. I drew these completely differently. I drew this one with lengths and then I went to angle measures. I do this one off of one length angle measure and the angle measures. When the angle measures and the length of this one side were the same, it automatically made these sides the same too. This one has to be the same. Okay, so there's no other way to draw this. So that also shows that third congruence postulate of side angle side. So yes, this is congruent. And finally, there's one more postulate or theorem that shows triangular congruence, and that would be the side-side-side congruence theorem, which says basically that if two triangles, stop doing that. Okay. Anyway, it shows that if three sides of a triangle are the same as the three sides of another triangle, the two triangles have to be congruent and they have to share the same side measurements. Anyway, that's what these are four theorems that show that you can use to determine if triangles are congruent to each other. You need to check to see if the side lengths are the same. Notice that these three all have two side lengths that are the same and one angle. This has three side lengths the same with no angles. The only one that has two angles and one side is the angle side angle. So for the most part, if you have two sides that are, actually this doesn't show congruence, so I take that back. This is not a congruence one. So the two that show that there's three that actually show congruence. The side angle side, the angle side angle, which these two are kind of the same. I've always kind of considered them very similar because this has the angle squeezed between the sides, this has the side squeezed between the angles, and then you have side, side, side. So those are the three different arrangements of sides and angles that if two triangles have that same arrangement, you can assume the two triangles are indeed congruent.